Alright guys, Mr. T here. This is another video. This one is on the forces problems, solutions for the forces questions for the year 10 physics test revision. So, sorry about that. Force is equal to mass times acceleration is Newton's second law. This is the last kind of equation you need to be able to deal with. So, force is equal to mass times by acceleration. Just remembering that the force in newtons, so you're going to write the force in newtons as the units, but that's only going to happen is mass is in kilograms and acceleration is in meters per second. So keep that in mind. Sorry, meters per second is acceleration. Okay, so we're going to scroll down, do some of these questions. They're not going to be set out like this in the test. They're just going to ask you for one answer, but this is asking you to put in all of the unknowns into the lines there. So acceleration is 2 meters per second, so you can already answer that. 2 meters per second. It's got a mass of 3,000 kilograms. So with a triangle, force is equal to cover up force. It's asking for the force, so force is going to be equal to the mass times by the acceleration. The mass is 3,000 kilograms times the acceleration of 2. It's going to be 6,000 newtons. Capital N. A bowling ball would require what force to accelerate down an alleyway at a rate? So you've got a mass, you've got an acceleration. Force is equal to mass times acceleration. It's going to be 10 times by 3 is going to be 30 newtons. So the force is 30 newtons. The mass is 10 kilograms. The acceleration is 3 meters per second. Sally has a car accelerating 5 meters per second. If the car has mass of 1,000 kilograms, how much force does the car produce? So it's asking for force again, is equal to mass times acceleration. Mass of 1,000 times by 5 is equal to 5,000 newtons. So 5,000 newtons, 1,000 kilograms, acceleration is 5 meters per second. What's the mass of a falling rock if it produces a force of... So here we know the force already. It's asking for the mass instead, and it looks like we're missing acceleration, but remember, anything falling on the surface of the Earth accelerating at the rate of gravity, which is 9.8 meters per second. So we've given the force 147 newtons. So looking at the triangle, force, mass, acceleration, we're looking for the mass. So mass is going to be force on acceleration. The force was 147, the acceleration was 9.8. The mass must be 15 kilograms. So mass is 15 kilograms, acceleration is 9.8 meters per second. Scrolling up, what's the mass of a truck if it produces a force of 14,000 newtons, accelerating at 5 meters per second? So we know the force, we know the acceleration. So it's just like last question. Mass is equal to force on acceleration. The force is 14,000 divided by the acceleration of 5. 14,000 divided by 5 is 2,800 kilograms. So force 14,000 newtons, mass is 2,800 kilograms, acceleration is 5 meters per second. Alright, keep scrolling. What's the acceleration of a softball if it has a mass of 0.5 kilograms, hits the catcher's glove with a force of 25? So we know the mass, we know the newtons, we're asking for the acceleration. So remembering the triangle, force, mass, acceleration. What's the acceleration? Cover up acceleration. Acceleration is going to be force on the mass. The force was 25 newtons. The mass was 0.5. 25 divided by 0.5 is 50. meters per second, because the units were in kilograms and newtons. So force was 25 newtons, mass was 0.5 kilograms, acceleration was 50 meters per second. Your own car has a mass of 2,000 kilos. If your car produces a force of 5,000, how fast will it accelerate? So, just like before, acceleration is equal to force on the mass. The force is 5,000 divided by the mass of 2,000. And that comes to 2.5 meters per second. So force of 5,000 newtons, mass of 2,000 kilograms, acceleration of 2.5 meters a second. Sally wants to accelerate even faster than problem 3. She removes 500, so she makes her car lighter. How fast will her car accelerate? So her car's now 15... shaking it around. Her car's 1,500 kilos now. It still produces the same force as before. So according to Newton's second law, force is equal to mass times acceleration. If you got the same force but you've reduced the mass, you should accelerate faster. Why? Because acceleration is force over mass. If force remains the same and you're dividing it by a smaller number, and that smaller number is going to fit more times into the original number, the acceleration that results will be bigger. So now the force is still 5,000, but you're dividing it by a 1,500 kilo car. The acceleration is 3.33 meters a second, which you can see is a greater acceleration than it was before, simply because she lightened the car by 500 kilos. So the force was 5,000 newtons like before, the mass was 1,500 kilograms, and the acceleration was 3.33 meters a second. Sally challenges you to a race. On the first turn, you run off the course and your car strikes a large bale of hay. You're still making 5,000 newtons of force, but it only accelerates, so it's accelerating slower. We can use that information to work out what the mass of the car is. How? Use the triangle, force over mass times acceleration. We want to know what the mass of the car is because we know the acceleration and the car's still providing the same power. So mass is going to be the force over acceleration. The force is still 5,000. The acceleration is only 2. 5,000 divided by 2 is 2,500 kilograms. So force is 5,000 newtons. Mass is 2,500 kilograms. Acceleration was 2 meters a second. And this looks like the last question, I believe. Even tough. What? Even though she's way ahead of you, Sally switches her car. She turns on the NOS. The nitrous oxide allows her car to develop 10,000, so double the force. What's Sally's acceleration if she has a mass of 500? So, again, force, mass, acceleration. We want to find the acceleration. So acceleration is going to be force on the mass. So force was 10,000 newtons divided by the mass of 500. 10,000 divided by 500 is 20. So she's really boosting there. 20 meters per second. So 10,000. That looks like a 20. 10,000 newtons. Mass of 500 kilograms. Acceleration of 20 meters a second. So I think that is the last question there. So that's some use of the force is equal to mass times acceleration equation. Hopefully that helps you out with your solutions and practicing for the test. And I'll see you in the next video.